Hi, welcome to my free Java video course, Lesson 1. My name is Markus Biel. I'm a software craftsman with 14 years of experience in Java. My goal is to teach you Java in the easiest possible way. You can actually help me by sending feedback to my email address. I need your feedback for two reasons. First, based on your personal feedback, I'm going to continuously improve the training. Second, your feedback will motivate me to continue and record further lessons. I will answer every email. Thank you. Okay, we will start with a briefing, which is basically a lot of theory in the beginning. I'm sorry. Second, we will do a practice session where we will actually write our first Java program. Finally, we will do a short debriefing where we will recap what we learned so far and add some more theory where needed. In this first lesson, I'm going to introduce you to the following 15 Java keywords or concepts which you will need to understand your first coding session later on. Please note, especially if you already know some programming, I really focus on not using any term before I officially introduced it. Getting a keyword explained using concepts I don't know is something that always ticks me off in classes, so I aim to do better in this aspect. Therefore, intentionally, I might explain a few things not 100% academically correct in the beginning. Where necessary, I will add the academically correct later on. As stated earlier, my goal is to teach you Java in the easiest possible way. If I can achieve this by looking just a bit stupid, that's fine with me. Last but not least, this is really only a first introduction. It's okay if you don't directly grasp everything. We will go in more detail and recap the important parts later on. A package, or better a package structure, is like the file structure on your computer. It helps to organize the different files of your program. The top or root folder of a package structure is usually the organization's domain name, in reverse order. In my case, that would be CamelCase, for example. If you don't have a domain for the program you're writing, it's okay to invent your own domain name, but make sure it's a unique name. The reason for this is that the name of a program file is actually a combination of its own name plus the full package structure of the package it resides in. There are millions of other programs out there, and chances are high that someone else has already used exactly the same program file name before you. As Java code is heavily shared worldwide, a strategy was needed to come up with a unique name to prevent name clashes. Each domain names can technically exist only once. Therefore, using a domain name as the prefix for your package name is the default. Think of the package name like an absolute file name of your program file. Using a package name is optional, but I highly recommend you to do so, even for the simplest program. When used, the package must be declared in the first line of your Java program. The package name is starting with a domain name in reverse order, as stated before. The reason for this is that the package name from left to right gets more and more specific. Using lowercase and singular for package names is the recommended default. Last but not least, the package name also serves as a high-level description of all the program files related to a certain topic. Code written for lesson 1 of this Java course would end up in a package called CamelCase Java course lesson 1, for example. Please choose package names thoughtfully. It's not just a stupid name. The package names reflect the internal structure of your entire program. Last but not least, I recommend you choose package names related to your specific business topic, rather than just using technical terms. Good names are key. To simplify programming, every program file will reuse existing code. To do so, you have to import the code into your program file. In our program file, the import statement or import statements will follow directly after the package declaration. Here you can also see how the package name must be included in the import statement, as it is actually part of the program's file name. You may import specific files or all files of a certain package using the star symbol. Besides regular import statements, there are also static imports, which we will cover in detail at a later time. A simple program can easily consist of thousands, if not tens of thousands of code lines. It's very easy to get lost in such a big pile of information. Therefore, it's really important to impose a structure on the program code. Besides using packages, as explained before, in Java, the program code is classified into different units of code. Such a unit we call a class. The programmer is the one who may decide how to name and structure packages as well as classes. One aspect of Java is to improve cooperation between business clients and programmers. The client is able or should be able to tell what he wants. The programmer is able or should be able to know how this can be expressed in code. The closer this code is related to the business, the easier the cooperation between programmers and business people will be. Forming a common language related to the business and used throughout the code is therefore of utmost importance. By convention, the name of a class in Java should be a noun, starting with a capital letter. The opening curly brace defines the beginning of the definition of the class, where we will later write all our code related to a car. The closing curly brace defines the end of the definition of the class. A class should be focused on only one topic. As a recommendation, keep your classes as small as possible to improve reusability as well as readability. A class usually consists of one or more methods. As the name implies, it defines a method of how to achieve a certain thing. Like a method double could be defined to calculate the double amount of an input given. Methods are sometimes also called functions. For now, while not 100% academically correct, it's okay to use the terms interchangeably. By convention, the name of a method should be a verb that best describes the purpose of the method. Methods define the actions you can execute on classes, so they further refine the structure of our program code. Methods can do pretty much everything for us. Methods can operate not only on numbers, but also on text, colors, sounds, you name it. A book would have chapters. Every chapter would have paragraphs, and every paragraph would have sentences. Structure your Java code in a similar way. The package name would be like a chapter. A class would be like a paragraph, and a method would be like a sentence. For example, methods internally can call other methods, which will then form a hierarchy of methods calling each other. As a programmer, it's up to you of how you want to structure your code, how long you want a method to be, which method will use which submethods. I would recommend, however, to always think of the current level of abstraction, just as if you would write a book. For example, a method prepare dinner could internally call a method prepare appetizer, followed by a method called prepare main course, followed again by a method called prepare dessert. The prepare main course method, for instance, could internally call a method called boil water. Mixing the levels of abstraction would, for example, mean to have a method prepare dinner, internally calling a method prepare appetizer, directly followed by a method called boil water, without having a prepare main course method surrounding it. Coming up with clean structure is key in programming. Make your code speak to you. Today, with programs of millions of lines of code, the most important part of programming is structure and readability for humans. As soon as you start to lose focus and have difficulties in understanding what a program does, chances are high you will misunderstand some concept of the code, and so you might introduce an error. Keep your methods as short as possible. As a rule of thumb, I would recommend 1 to 3 lines, with 20 lines as a maximum. The definition of a method follows a similar concept of that of a class. First, we define the name of the method. As stated before, use a verb and start with a lowercase letter. The name of a method is followed by an opening and closing bracket. This is the place where we may define the names of 0 to an unlimited amount of input fields. When using the method later on, you will need to choose a value for those values. These values are called method parameters. In order to further improve the structure and readability of your code, I recommend you to use as few as possible method parameters, with 3 to 5 parameters as a maximum. Everything more than that will not be readable. The opening curly brace defines the beginning of the method definition. Closing curly brace defines the end of the method definition. Later, we will define the actual code of the method that will go into the space between the curly braces. As the name implies, a variable is a variable value, a placeholder for a value that you can set. The value of a variable may change while the program is running. For example, when a certain value is calculated over the lifetime of your program. Variables can be used as input or output values of methods. For example, variables can be of different data types, like numbers or text. Data types we will cover in detail at a later time. Just for example, possible variable names for a car could be my old car, my Porsche, or mom's car. There are different types of variables, like instance variables, static variables, local variables, parameters, or arguments. We will cover the differences in a later session. Public is an access modifier that defines that any class from any package may use the class or method with public access modifier. Besides public, there are also other access modifiers like private, default, or protected. Here we are only skimming the topic. In a later session, we are going to cover access modifiers in detail. Here you can see the access modifier public in action. The class as well as the method now both have public access defined. For every method, you actually have to define a return value. Ironically, even when you don't want to return any value at all. In this case, you will set void as the return value of the method, to explicitly define that the method will not return a value. Besides void, a method can actually return any kind of data type. Here you can see the void return type in action. Our drive method is supposed to make the car drive, which is expected to execute an action, but not to return any value to us. As a rule of thumb, it's good design to differentiate between query methods which return a value but do not alter the state, and command methods which alter the state but do not return a value. In respect to this best practice rule, drive is a command method and therefore does not return any value. The @ symbol indicates an annotation. We will cover annotations in detail in a later session. Just for now, I want you to know that with @test, we indicate that a given method will be used as a test. When a class, a variable, or a method name consists of more than one word, in Java you use an uppercase letter to indicate the beginning of a new word. This is called CamelCase, as the ups and downs of upper and lowercase letters look like camel humps. In other programming languages, an underscore is used to separate two words from each other inside a variable name. In Java, however, CamelCase is used instead. To indicate the end of a sentence, we use a dot in English sentences. In Java, however, the dot has a completely different meaning. The dot between the variable car and the method drive indicates that we want to execute, or we would alternatively say call the method drive on car. As the dot is already used to indicate a method being called, the colon is used to indicate the end of a statement in Java. Here we can see an example of a test method that is expected to test that our car drives. The method drive is executed on car with a value of 100. Colon says, I want this to be executed, period. I talked about classes already. I said that a class is a way of structuring code in Java, a unit of code. This is perfectly true. However, it's only part of the magic. A class is like a template, like a definition of what you want the class to do for you later on, when the program is running. The class car, for example, defines the behavior of a car. However, when your program is running, we say at runtime, there will usually be a number of cars. Each car may have its own unique set of values. One car might leak oil, so the value of oil could drop to 0 while the program is running. So a class is like the human DNA, a definition of how something should be created when the program is running. When a Java program is running, it would usually create a certain number of objects that will exist as a set of values in the computer's memory, and those values might change while the program is running. Each program language follows a certain concept. Java is an object-oriented language. Everything is focused around objects in Java. In Java, writing classes is a way of defining a model which focuses on necessary aspects to solve a specific problem. It needs the brain powers of a clever Java programmer to fully understand a problem and to extract a theoretical model from it and transfer this model into classes. The skills of the programmer will have high impact on how precisely a problem is transferred into a class model. Simply speaking, the more accurate this is done, the less code has to be written and maintained. The faster the program will run, the less errors it will have. The power of Java is to be able to define an executable model, like a virtual machine on your computer, with concepts and names taken from the real world, which heavily improves the communication of the programmer and the business client. Programmer and business client can both talk of a car, while the one is talking of a real car and the other of the representation of this car on the computer. They will understand each other. Here we see a simplified definition of a class car. Now imagine a game where each player creates a car when the game starts. The program in this example might create 3 different cars at runtime. Now I talked about classes and objects that will be created from those classes. But how will these objects be actually created? We will need a method that will create the objects for us. This is a very special method. It is called on a class and will create an object each time we call this method. But as soon as the object exists, we cannot call this method anymore. The special method is called a constructor, as it is used to construct objects from class files. To create a new object of time car, you write new car. For example, the constructor in this case, just like a method, is given two different numbers, one for the age of the car and one for the maximum speed in our example. When the program is running and executes this line, a new object will be created in your computer's memory. We talked about variables already. However, before we can use a variable, we need to define it beforehand. Car my Porsche colon is an example of a variable declaration. We declare the variable, which we called my Porsche, of the type car. Now that we have a variable declared, we have to allocate the object we created. Variable declaration, object creation, and allocation can all be done in one single line. So this line reads as: when the program is running and when this line of code is executed, create an object of type car with first value 1 and a second value 320. Then create a variable of type car and give it the name my Porsche. Last but not least, assign the car object to the variable named my Porsche. After this line, whenever we use my Porsche, we actually reference the object created in memory. Also, you might notice when looking at this line of code, we put two values into the constructor of car. But without looking into the code of the class car, we wouldn't even know what their meaning actually is. This is one reason why you should try to limit the number of variables used in a method, as well as in a constructor. The less, the better. Okay, that's it for now. Don't forget to send me your feedback. I'm highly interested if you were able to follow my explanations. Please give me feedback what you did or did not understand, where I was too fast or too slow. I will answer every email and I will try my best to incorporate your feedback in the sessions. Actually, I might even re-record a session based on your feedback. Thanks for watching and hope to hear from you soon.